Welcome to Study Loop.
Okay, so for this problem, we're given a helicopter that has 4 blades, and each of them is 3.4 meters long from the center of the blade tip. Okay, so that means we could take R to be the distance between the center and the tip of the blade. So that's our R value then. So R is going to be 3.40 meters. And we're also given an angular velocity of 550 revolutions per minute. And then we're being asked to find the linear velocity, v, in part A, and then the radial acceleration in part B. Okay, so first let's find the linear velocity v. So linear velocity is equal to the angular velocity, which is omega, times r, the distance here. Okay, but we first want to make sure that the angular velocity has the proper units. So in order to use this equation, we want the angular velocity to be in units of radians per second. So now we have revolutions per minute, so we'll convert it then. Okay, so we know that in one revolution, we're going to have 2 pi radians. So multiply by 2 pi per revolution. Okay. And we know 60 seconds in a minute. So multiplied by 1 minute over 60 seconds. So now the minutes cancel out and the revolutions cancel out. So we just have 550 times 2 pi divided by 60 seconds. So I'm going to get 57.6. And now the units are going to be in radians per second. Is that radians in the numerator here, and then seconds in the denominator. Okay, so now I can plug this value in the equation for the linear velocity v here. Okay, so I'm going to use the calculator as calculated. I'm going to use the value just calculated for omega, and I'm going to plug in r equals 3.4 meters to get v here. So if I do that, I'm going to have a linear velocity of 195.8 meters per second. So that's my linear velocity. And then for the radial acceleration, I'm going to use the equation v squared over r, so it's going to give me the radial acceleration. Okay. So now if I plug in the value I just calculated for v, the linear velocity, and I plug in r, which is given to me, I could solve for the radial acceleration. So I plug in those values. I'm going to get a 11,280. That's going to be in meters per second squared. But now I want the answer in g's, okay? So I know 1g is the acceleration of gravity. So g is equal to 9.81. meters per second squared. So I can get the number of G's of acceleration by taking the 11,280 and dividing by 9.81. So it's going to give me the G's of acceleration. Okay, so I can plug this into a calculator, and I'm going to get 1,151 Gs. So the radial acceleration is going to be 1,151 Gs.